Morena everyone, I'm Jo Carpenter and I'm going to be talking about impacts of forest pests and environment on fruit abundance and quality. And this is work we are doing in partnership with the Tūhoe Tuawhenua Trust. And this research has really been initiated by Tūhoe mā Tauranga Māori that's been collected and recorded over many years, especially by Phil Liver. So I just want to acknowledge Phil and all the elders that contributed that knowledge because this research wouldn't have been possible without it. So thank you. So at the beginning of the More Birds program, we had several hui with the Trust to discuss and co-design research that both aligned with the Trust goals and also aligned with the general theme of the More Birds program. And one thing that became immediately apparent was the importance of kiraru to the Trust and how much they really wanted to recover kiraru back into tuawhenua lands in their previous abundances. So we needed to know what's restricting kiraru, what's preventing their recovery. We did a national literature review and found that predation by introduced mammals is the #1 limiting factor for kiraru in intact forests. But the review also really highlighted the importance of forest quality and food resources because kiraru tend to breed in response to food availability in the landscape. But of course, often these mammalian pests determine the outcome of those reproductive attempts. And this aligned as well with what Tūhoe elders had noticed, which was that it was really important for kiraru to be fat and to be in good condition for breeding. And they'd also identified the fruits that really led to that great condition in kiraru, especially miro or toro miro, as they call it. And this was really relevant because I'd also noticed that their forests were changing over time. The tuawhenua forests appeared a lot less resource rich than they had been in the past. They were drier, the fruit was smaller, there was less fruit, and there were several potential drivers behind these changes. So the first was logging. Between 1950 and 1975, a lot of the podocarps were logged out of tuawhenua forests. And these podocarps would have been really important food sources for kiraru. Of course, there were also introduced mammals that started appearing in the forest, possums, rats, but also browsers such as deer and cattle as well. And finally, there've been observations around changing climate. So the forest appeared drier, there were less frost days, and this could be impacting the phenology of fruits and the forest itself. So we co-designed 2 studies to look at how these factors affected the abundance and quality of kai for kiraru. So the 2 studies were how do possums and shiprats impact fruit abundance, both separately and together? And secondly, what environmental variables influence fruit quality and abundance in Tawa? The reason we focused on Tawa was because Tūhoe elders had specifically noticed that Tawa fruit had changed. It was small and shriveled compared to how it used to be, and there was a lot less of it, which is surprising because these forests are quite Tawa dominant now. So starting with the first question, how do possums and shiprats impact fruit abundance both separately and together? Um, like John and Adrian have noted, we can become so focused on the predatory impacts of these pests that it's quite easy to forget that a lot of their diet overlaps with our birds' diet, and so they're also competitors with our birds or food diverters. And tuawhenua elders had noticed or that observed that competition with possums could have been one of the reasons for declining kiraru numbers within their forests. There's been a couple of studies that have shown that possums can affect the abundance of several tree species fruits. And we also know that when you do combined rat and possum pest control, you can increase the abundance of fruit in your forest system. But no studies yet have ever separated the impacts of possums and rats in terms of how they're affecting fruit and flower abundance. But it's important to figure this out because often a lot of pest control regimes are quite effective at suppressing possums over long time spans, but much less effective at suppressing rats. they might just suppress rats briefly before the rats bounce back to even higher levels. So if possums are the main culprit suppressing fruit and flower availability, then this kind of control will still have positive impacts in terms of increasing food resource for birds. But if rats just step in and fill the niche of the suppressed possums and eat all the flowers and fruits that are now available, there's going to be a negligible benefit. So we set up a study using a before-after control impact design on 8 25-hectare blocks around Ruatahuna, which is in central Te Urewera. We collect seed and flower fall monthly, and we also index rats and possums every 6 months. So after 18 months of this baseline monitoring where we didn't do any kind of pest control, we started the control, and we have 2 blocks that just control possums, 2 blocks that just control rats, 2 blocks where we control both species, and 2 blocks where we don't do any treatment. And I'd just like to really thank Slane and Pato who do most of this work, and they're fantastic. So here we are at the start of the study, setting up our seed rain traps. Each block has got 30 of these traps on it, and 10 of the traps are targeted to catch toro fruit because of its importance to kiriru, whereas 20 of the traps just are randomly placed in a grid to collect forest level seed fall. And from the first 18 months of the study, these were our pest indexing results. So for possums, we use chew cards, and for rats, we use tracking tunnels. And for possums, the average chew card rate was 13%, and for rats, it was 37%. But just to note, this is before we started any pest control. Oops. So we started the pest control in spring of last year. We use A24s and poison and bait stations for rats, and for the possums we use leg hold traps and cyanide. And when we control both species, we throw the whole lot at it. So it's still early days in terms of our pest control. We haven't been able to index the pest yet to see what impact we are having. But we will continue doing our suppression, and we'll continue collecting the fruit and flower fall monthly, so that we can start seeing what's happening with these pests and whether we can disentangle their impacts on those forest resources. So our second question was, what environmental variables influence fruit quality and abundance in Tawa? We separated this into 3 strands. So the first was a national study analysing environmental drivers of variation in Tawa fruit and crop characteristics across the entirety of Tawa's range. And that's what our master's student, Oscar, is going to speak about next. The second strand went back to Tuawhenua lands, and it aims to look at Tawa fruit within Tuawhenua lands and across the natural environmental gradients that occur there, so dryness gradients, altitudinal gradients. And lastly, we kind of wanted to go back in time a little bit and investigate how the environment may have changed within Tuawhenua forests, and how that would be affecting Tawa and its fruit by sampling Tawa tree rings and also looking at climate data. So it's that project that I'm just going to talk about for the rest of my talk. So we know in quite a few plant species that the size of their fruit is directly related to how much water availability is in the landscape. So it seemed likely that shrinkages in Tawa fruit could be related to drought stress or less water being available. And this aligned as well with elders' observations that the Tuawhenua forests were drying out. They were much more crackly and windy. So there were a few drivers of potential drought stress in Tawa. It could have been the logging. The removal of podocarps had changed forest structure and could have affected the amount of moisture in the forest. Secondly, browsers had really removed a lot of the understory, and this again could be affecting that microclimate, and it could be a lot less humid and moist on the forest floor. And finally, there could be, just general climate change impacts. Less precipitation, warmer days could all be creating more drought stress in Tawa. And the way that we wanted to look at drought stress was by coring Tawa, and then we can sample stable isotopes from the separate tree rings and look at how Tawa are using water over time from those stable isotope signatures. So to try and disentangle some of the drivers that could be behind drought stress in Tawa, we cored trees both in logged and unlogged sites around Ruatahuna. And this picture on the left here is Puki carefully sliding one of these cores into a straw for safekeeping. So we had several predictions about how these different drivers would manifest in our results if they were true. So the first was logging. We thought if logging was the main driver of drought stress, that then we'd see different water use patterns in Tawa at log sites versus unlogged sites. And this change would occur after 1950 when logging started. However, if it was browsing by ungulates that was the main driver of changed water use in Tawa, then all sites would be affected equally, regardless of whether they were logged or not, and this would align with the timing of deer arrival. Finally, if it was more climate change that was the issue, we expected that all the sites would be affected, that our historic climate records would also show a change in either precipitation or temperature, and that this change would align with what we were seeing in the tree rings too. So it's still early days for this research, I'm afraid, but here are all the cores that are just laid out by Oscar for drying. We first need to check that Tawa give accurate tree rings, that we can cross date the tree rings accurately. But early indications suggest that some of the trees we cored are over 300 years old. So assuming we can create accurate dendrochronologies from these, we'll have an incredible archive of environmental conditions experienced by these trees over time. So what's next for the project? Well, we'll continue doing our fruit data collection and our pest control on our blocks, so that in the next couple of years we can figure out how possums and rats are affecting the availability of food for keriru. We'll cross-date our Tawa dendrochronologies, hopefully, and sample them for stable isotopes, and then we'll pair those findings with Oscar's results about how changing environment affects Tawa fruit size and abundance. And once we have all the results from these two projects, we'll have a much better idea of how food resources for keriru have changed in these forests over time, what the main drivers of that change are, and how we could potentially address them. Thank you very much. Are there any questions?
You're muted, Susan.
Thanks, Adrian. Sorry about that. I have one question for you, Joe. Just thinking about the timing of the fruiting and whether you think your Baccy study is going to deal with that, because we have these big interannual variations in the fruiting.
Yeah, that's a very challenging aspect of it. Having a longer study would definitely be better, but to some degree we are slightly buffered by the design. By having a before-after control impact, it should mitigate the challenges that we might have if for example, kakatea have a really big year next year. We would still expect to see that our sites that have no pest control, the kakatea, there'll be less of it than the pest control sites or something along those lines. So hopefully we should manage for it to some degree.
Thank you, Joe. Are you just doing pest control in the 25 hectare blocks, or do you have a buffer zone? Do you think conditions outside the plots affect food resources?
We don't have a buffer zone, but our seed traps are generally within the centre of the blocks. So in a way, a lot of the block is buffer. Um,
Great.
but
I'll stop you there. Thank
I'll
you.